welcome to my new video based on electrostatics, part number 2. In this video, we are going to discuss about the electrostatic force. As we have discussed earlier that like charges repel and unlike charges attract each other. So the force which insists them in doing repulsion or attraction is called as electrostatic force. So there is a Coulomb's law which justifies how this force explains us about the attraction and repulsion between two charged particles. According to Coulomb's law, the electrostatic force of repulsion or attraction between two charges, let us suppose Q and Q naught. The charges has the magnitude Q and Q naught, their distance is R, let us suppose. So Coulomb's law states that the electrostatic force between two charges is directly proportional to the product of their magnitude, inversely proportional to square of the distance between them, and depends on the medium under which these charges are placed. So if we equate or adjust these two equations, what we get, left side is common, Q naught by R square, and after removing the sign of proportionality, there is a constant of proportionality called as dielectric constant, denoted by K, Q naught by R square. Okay, so this is the electrostatic force. Here the value of K is 1 pi 4 pi epsilon naught. This epsilon naught means free space in vacuum. Epsilon is the permittivity which suggests that electric field lines are passing or not. Okay, the medium is going to permit the passing out of electric field lines or not. This is the permittivity, and its value is 8.85 into 10 raised to power minus 12. If you equate this into this 1 by 4 pi epsilon naught, and if you take epsilon naught into left and F as in right side, what will be the values of unit? So this epsilon naught becomes, this is 1 by 4 pi epsilon naught. Epsilon becomes here Q naught by F R square, right? So Q is Coulomb. This will become Coulomb square by force is Newton. Distance is in meter, in MKS unit, meter square. Is it okay? And the value of K is 9 into 10 raised to power 9. The value of K is 9 to 10 raised to power 9, and it will become Newton meter square per Coulomb square. Is it okay? Is it okay? Moving on. So this is how Coulomb's law justified. Now moving on to a question based on Coulomb's law. But before that, I'll explain you about the electric field. As the name suggests, electric field is the space around a charged particle under which, let us suppose the space is like this. So this space is called electric field if up to this distance only another charge, if we bring another charge, then it's supposed to be have attracted or repelled by this charge. Okay, so if any other charge experience an electrostatic force under a particular space, this is called electric field. Is it okay? So let us suppose we want to know about the charge, whether it is of positive charge or negative charge. So what we can do to detect this charge? We have to take a particular charge, let us suppose 1 Coulomb, positive 1 Coulomb charge, a small unit charge, and we know that this is the positive charge. So if it is attracted by it, that it means this is unlike, means negative charge, and if it is repelled by this charge, then it means it is positive charge. So the charged particle which is used to detect the charge, whether it is positive or negative on other particle, is called test charge. What is it? Test charge. And it will be always of one magnitude. Whereas the charge which we want to justify that whether it is positive or negative is called source charge, from which electric field lines are moving on or emitted or absorbed. Okay, so this is electric field. Now a particular charge consists of the intensity to oppose or attract another charged particle. This is called electric field intensity, and it is defined as the force per unit test charge. Okay, and this limit of charge moving on up to 0. Okay, test charge is very small, that's why we are taking this limit. So by Coulomb's law we have studied that the value of force is 1 by 4 pi epsilon naught q naught by r square, and this is q naught. Then q naught is cancelled with q naught, so electric field intensity has the formula of 1 by 4 pi epsilon naught q by r square, and the unit will become force, which is Newton, charge, which is Coulomb. Is it okay? So far we have discussed about electric field intensity. Now come to a numerical based on Coulomb's law. It is very simple numerical. So what is it? Using Coulomb's law, calculate the force between a negative charge, this is 4 microcoulomb, micro means 10 to the power minus 6, and a positive charge of 6 microcoulomb. What is it? 6 microcoulomb. So 6 into 10 to the power minus 6 coulomb. Okay, and the distance between these two is given to us 0.12 meter. Alright, value of k, if it is not given, then also we know it. Okay, so this is 9 to 10 to the power 9. Now the thing is, apply Coulomb's law, which is k q1 q2 by r square. If we take this, k is given to us, q1 is this, just take the magnitude, 4 into 10 to the power minus 6, q2 is 6 into 10 to the power minus 6, and the r, the distance is 0.12 whole square. If you sort it out, means 6 4s are 24, 24 into 9, 9 4s are, okay, one thing we can do, take these 3 together, and 10 to the power 9 minus 6, 3 minus 6 minus 3, and it will become 0.12, point cancel out, 12, this will become 100 and 100, 4 3s are 12, 3 2s are 6, 3 4s are 12, 3 3s are 9, and 2 1s are 2, 2 2s are 4. So it will become 1.5 into 10 to the power 4 minus 3 1, that means 15 Newton. Is it okay? So in this way we have discussed about the Coulomb's law. Rest of the topic we'll discuss in our next class. See you then. Till then, and don't forget to subscribe my channel. Thank you.